Hello and welcome. Today, we're diving into the fascinating world of generative AI, a groundbreaking technology that's transforming the way we create and innovate. From generating text and images to producing lifelike videos and music, generative AI is reshaping industries and unlocking new possibilities. In this session, we'll explore what generative AI is, how it works, its origins, and its real-world applications. By the end, you'll have a clear understanding of this revolutionary technology and how it's impacting our world. So, let's get started. Generative AI refers to a type of artificial intelligence designed to create new content. Unlike traditional AI, which focuses on making predictions or classifying data, generative AI produces entirely new outputs based on patterns and relationships it learns from existing data. For example, it can write articles, generate realistic images, compose music, or even simulate human voices. At its core, generative AI uses advanced machine learning models to mimic human creativity, making it a powerful tool for innovation. Now, let's understand the mechanics of generative AI. The process begins with training a machine learning model on a dataset. This dataset can include text, images, videos, or any other type of content. The model learns the underlying patterns, relationships, and structures within this data. Once trained, the model can use this knowledge to generate new content that resembles the original data. For instance, if the dataset includes thousands of paintings, the AI can create a new artwork inspired by the style of those paintings. One of the key techniques used in generative AI is supervised learning. Here, the model is provided with input data and corresponding labels, allowing it to learn by example. Another approach is unsupervised learning, where the model discovers patterns on its own, without labeled data. For generating high-quality outputs, generative AI often relies on deep learning architectures. A popular example is the use of transformers, which power language models like GPT, and generative adversarial networks, or GANs, which excel at creating realistic images and videos. At its core, generative AI is designed to create new data that closely mirrors the original data it was trained on. Unlike traditional AI systems that predict outcomes from given datasets, like predicting the weather or identifying objects in a picture, generative AI goes one step further. It learns patterns and structures from its training data and uses that knowledge to generate entirely new outputs, whether it's a piece of text, a brand new image, or even a completely original song. Now, let's take a step back and look at where generative AI all began. The concept of AI and machine learning has been around for decades. In fact, the roots of generative AI trace all the way back to the 1960s, when early forms of artificial intelligence began to take shape. During this time, researchers developed some of the first chatbots, simple programs designed to engage in conversations with humans. These early systems, though basic by today's standards, laid the foundation for what would eventually become generative AI. But it wasn't until 2014 that generative AI truly took off. This was the year generative adversarial networks, or GANs, were introduced by a researcher named Ian Goodfellow. GANs revolutionized the field of generative AI by introducing a two-part system that could produce incredibly realistic content. Here's how GANs work. They consist of two neural networks, the generator and the discriminator. The generator creates new content, while the discriminator evaluates how realistic that content is, comparing it to the original data. They work together in a feedback loop, where the generator learns to produce better and more realistic content, and the discriminator gets better at distinguishing between real and generated content. This constant back and forth pushes the system to improve continually, resulting in the ability to produce highly realistic images, videos, and even audio. Before GANs, generating anything remotely lifelike was a major challenge for AI systems. But with the introduction of these adversarial networks, generative AI broke barriers, achieving results that previously seemed impossible. It could now generate photos of people who didn't exist, artistic styles from famous painters, and even deepfake videos that look almost indistinguishable from reality. To give you an example, imagine seeing a photo of a person, someone you've never met before. That person might look familiar, even lifelike, but the truth is, that person doesn't exist at all. GANs can create realistic human faces, each with its own unique features, expressions, and details, based purely on patterns learned from a large dataset of real human faces. This ability to generate synthetic yet realistic data opened the door for virtual assistants, video games, and even fashion design, all based on AI-generated content. Now, generative AI can write entire stories, create stunning artwork, compose music, and even generate realistic videos or human-like conversations. This breakthrough happened because of powerful models like GPT and DALL-E, which learned patterns from massive amounts of data. People loved it because it made life easier and more creative, helping artists, writers, students, and even businesses. With just a few words or clicks, anyone could create something amazing. That's how generative AI became a game-changer. At its core, generative AI uses models like generative adversarial networks, GANs, variational autoencoders, VAEs, and transformer-based models such as GPT, generative pre-trained transformer. Here's how it works. Training phase: the AI is trained on massive datasets, like thousands of sentences, artworks, or voices. The model learns the structure, patterns, and relationships in this data. Generation phase: after training, the AI can create new content. For example, text: GPT models predict the next word based on the previous words, allowing it to write full paragraphs. Images: GANs generate realistic images by having two networks, generator and discriminator, compete to improve results. Audio: AI models synthesize human-like voices by learning speech patterns. Why did it become popular? Because it revolutionized creativity and productivity. People could use it to write stories, emails, or code quickly, generate stunning artwork or design concepts, create personalized music or voiceovers. Generative AI gained traction due to its real-world applications, accessibility through tools like ChatGPT, DALL-E, and Midjourney, and its ability to empower everyone, from professionals to beginners, to create high-quality, unique content in seconds. Generative AI has seen remarkable breakthroughs thanks to advancements in computing power, access to large datasets, and sophisticated algorithms. Faster GPUs and TPUs now handle the immense processing demands of AI, enabling real-time applications. Massive datasets, such as images, text, and audio, fuel the training of large-scale models like GPT and Stable Diffusion, enhancing their accuracy and creativity. Commercial applications are flourishing across industries, from personalized marketing to AI-generated art, music, and text. User-friendly tools like Canva, ChatGPT, and Runway ML make these technologies accessible to non-experts, driving adoption and innovation. This synergy of technology and usability is rapidly transforming creativity, productivity, and problem-solving worldwide. Generative AI became popular because of its ability to generate new content, like text, images, music, or even videos, by learning patterns from existing data. At its core, generative AI uses models like generative adversarial networks, GANs, variational autoencoders, VAEs, and transformer-based models such as GPT, generative pre-trained transformer. Here's how it works. Training phase: the AI is trained on massive datasets, like thousands of sentences, artworks, or voices. The model learns the structure, patterns, and relationships in this data. Generation phase: after training, the AI can create new content. For example, text: GPT models predict the next word based on the previous words, allowing it to write full paragraphs. Images: GANs generate realistic images by having two networks, generator and discriminator, compete to improve results. Audio: AI models synthesize human-like voices by learning speech patterns. Why did it become popular? Because it revolutionized creativity and productivity. People could use it to write stories, emails, or code quickly, generate stunning artwork or design concepts, create personalized music or voiceovers. Generative AI gained traction due to its real-world applications, accessibility through tools like ChatGPT, DALL-E, and Midjourney, and its ability to empower everyone, from professionals to beginners, to create high-quality, unique content in seconds. Generative AI is not just about creating content in the moment, it's reshaping entire industries by providing real-time solutions to everyday challenges. Let's take a deeper look at how it operates seamlessly in various fields. First, we have AI-driven customer support. Virtual assistants like ChatGPT or Zendesk's AI assistant can respond to customer queries instantly. With AI processing, businesses can provide 24/7 support, answering questions, resolving issues, and even handling complex requests, all without human intervention. In real time, these AI assistants enhance user satisfaction by offering quick, personalized service. Next, real-time content moderation. Platforms like YouTube, Twitter, or Facebook use generative AI to detect harmful content like hate speech, fake news, and inappropriate images as they're posted. The AI scans, analyzes, and takes immediate action either by flagging, removing, or providing alerts for further review, all while the content is being shared in real time. Moving on to AI in healthcare. Generative AI models like IBM Watson are being used to generate real-time insights from patient data, helping doctors diagnose conditions, suggest treatments, or analyze medical imaging. AI can scan millions of records instantly, providing critical insights during emergency care or routine checkups, thus saving lives in real time. Now, consider AI in creative design. Artists and designers are using tools like DALL-E 2 or Runway ML to generate high-quality designs in seconds. Whether they're creating logos, ad concepts, or new illustrations, AI allows real-time collaboration, enabling creators to experiment and iterate rapidly, accelerating the design process. Then, there's AI for personalized shopping experiences. E-commerce giants like Amazon or Shopify use AI to suggest products based on real-time browsing data. Generative AI analyzes your preferences and adjusts the recommendations instantly, offering a customized shopping experience that feels intuitive and tailored to your needs. We've explored how pre-trained models and APIs can take you from idea to production-ready AI solutions incredibly fast. Whether you're fine-tuning models, crafting better prompts, or integrating APIs into your apps, the opportunities are endless. The best approach is to start small. Build a simple prototype, experiment with different APIs like Hugging Face, OpenAI, or Stability AI, and learn by doing. Once you're comfortable, you can scale up, optimize for cost, and explore advanced techniques like model fine-tuning or multimodal AI. AI is no longer just for research labs, it's a practical tool in every industry. And with APIs, you don't need to build the tech from scratch, you just need to connect to it. Happy learning! Remember, your luxury cuisine of AI knowledge is just around the corner, your premium AI experience is just within reach.